My name is Maaret Pyhäjärvi. So you now get why everyone is hesitant on my last name. The first name alone is giving people trouble in the US, and that's the usual. And my kind of break from the conferences is a break travel. So interestingly, this is public speaking in another format. I've been doing more talks than ever since COVID started, but I quit public speaking so that I could keep my commitment with kids, that I would not leave them to grandma's house. They could be at home rather than anywhere else. So in a way, I quit speaking 2 years ago, but I've been doing it than ever. I think I'm somewhere around 460 talks. I keep counting things, like I count many things. That's part of the way that I work. And my work currently, some of these pictures I just show a little bit of that. So yes, I do software, but I do software that resides on those embedded devices. And of course, the lovely, cords and all things going into the systems you see on the racks, they are not available when you put the weather station, which is basically a glorified thermometer on a little rock somewhere in the middle of an ocean. It also knows other things than temperature, but other things it does. So that's what I've been building for the last year and a half. Overall, I've been doing various things around software testing for 25 years, and I absolutely exploratory testing. And the talk that I wanted to share with you today, I delivered the first version of this talk a few weeks back in Eurostar as a keynote. And today, just kind of conveniently, I got this feedback from that conference presentation. And I just wanted to kind of share this with you in the sense that, I got a wall full of positive feedback. I hope I managed to do as well today as I did on that particular day, but I haven't rehearsed quite as heavily for today as I did back then. But seeing someone kind of give me feedback on like, this is not rocket science. Yes, I know, I'm not trying to teach you rocket science. And I am not trying to even build bridges necessarily between warring factions with this talk. But what I'm trying to do is let's have a conversation. And rather than having a conversation that happens kind of, in anonymous feedback, I invite you during this talk as I am going through this. And I invite you to have a conversation with me right after. And if this is coming to your night's sleep later on, you can always, every single day, you can find me on Twitter, and I am happy to have either a little bit more public conversation or a call, or you can just DM me and we can have those conversations. So all of this is to start a conversation and to talk about something that has been really, really important to me in my everyday work in Vaisala, in various other companies that I've worked with in the last 25 years. And the talk, I dubbed it as Automationist Gambit. So it's kind of like a story, a growth story in a way, into how I've come to view testing and what kind of testing I am introducing in my company with the embedded systems, which is working really nicely, but it also is requiring something out of the people that I work with, which is a growth mindset and an idea that we can be different than what we used to be before. So as the starting point for the idea of what is Automationist Gambit, when this whole remoteness started a year and a half ago, at some point I started seeing things in my Twitter feed mentioning this great, awesome movie, or actually a historical film series on Netflix, and it was called Queen's Gambit. It really caught my eye, the name alone, because as someone who doesn't speak English as my native language, Queen's Gambit doesn't really mean anything to me. So I did the usual thing that I always do. I would watch the movie, but I also Googled the name. And when I watched the movie, I was thinking kind of like, well, definitely no parallels here to testing as such. It's a movie about substance abuse, so I have absolutely no interest in making parallels to testing and substance abuse. Testing, like falling in love rather than anything negative. And the part that I make a parallel on was on my Googling. So when I Googled Queen's Gambit, I learned that it's a chess move, basically. It's a particular chess move where you open the game so that you move your pawns so that you have the white make an appearance of sacrifice with the C pawn, meaning that that little marker there on the green, giving it away, but it is also creating space in the overall game of chess, where even though you're sacrificing something in the beginning, you're actually giving yourself chances of winning in the end. So Queen's Gambit, it's one of the famous moves. The sacrifice gives you this possibility that the blacks on this game, they can't retain the pawn without having a disadvantage. And in that sense, it started kind of to resonate with me on the idea that is actually, with this particular idea, there is a parallel to testing. A most common conversation that I have had over the years of testing is this idea that we have manual and automated, and that they're somehow separate. Those who are keen on the manual side of testing, which, exploratory tester myself, I kind of might, go into that space a little bit. I often found myself in time on kind of like saying that, we need to make sure we have eyes on the software, we need to be exploring, we need to be paying attention, and kind of like, making the appearance that we need to sacrifice something if we go on the side of the automation, and the other way around. And I realized that this actually idea that you need to make some sacrifices and consider some sacrifices in order to win in the overall game, it is actually a really helpful way for me to reframe the whole thing that I think of in exploratory testing. And that framing, I call that now the Automationist Gambit. So I've learned over the last 3-4 years very actively to explore in a way where my opening move and my middle moves and intertwined moves are actually, sometimes they're more like manual thinking, even doing things with my hands, and sometimes my hands are actually writing that automation or running that automation, and I'm watching things unfold. So separating these two, like not separating these two, is actually making my testing and my organization's testing significantly better. So in a way, Automationist Gambit for me, it's an opening by sacrificing some of the material, or imagined material. This is something that we value quite often in this field, to win in the end. So I really wanted to try this out and see where I go. I also started noticing when I worked on this idea that in the last, let's say, 5 years or so, I have actually done active work in trying not to use airspace into warning people about automation anymore. Because every single time when I say that the automation might be taking away from something else, when I explain to a manager who's asking me how many tests we've automated, and I correct them and say that doesn't matter, and I go into this mode, it is actually this time that I use on warning and promoting the warning atmosphere. It is time away from me being part of the solution. And actually, when I go and join forces with the other people who are working good testing out in this space, I find that we're actually doing things where we're succeeding. So opportunity cost is something that is driving my thinking. So going back kind of like a step. So I talk about exploratory testing, and that's really the mindset in which I kind of live in all of my life of tester. Exploratory testing is this idea that Ken Kainer coined, I think 37 years ago, if I count correctly. I'm getting a little lost on the years. So it's been around quite a long time. And 37 years ago, when Ken was talking about it, it was not like it was a new invention that he made. It was just a term that he coined to describe a phenomenon that he was already observing in the smart companies in Silicon Valley back then. And by no means, this is not something that was only born in Silicon Valley. I've been doing some research in testing in Finland in the 50s when we got the first major computers and how the first kind of use of computers and programming started in Finland. We've been doing exploratory testing here since day one. we could never afford to go into the military style of writing very detailed test cases based on very detailed specifications. We were always scarce on resources, so we always had to do things in a smart way. And the idea with exploratory testing right from the beginning, it was this idea that looking at a single individual tester, it's not a smart move to give the test design to someone who is more senior, and then the execution to someone who is more junior, and then have that handoff between those two. But those two activities are so intertwined in agency, which is basically the power to make use of the learning you're doing in the moment, and also the attitude that goes with that power, so that you can make those connections and what is your next test. What's the next test you will run, no matter what way, but to get the kind of next information based on what you just learned out of the testing that you were doing. And you're doing this obviously to optimize for impactful results. So not missing out on relevant information, relevant bugs, but actually finding those things that you're expected to find. So the Cambridge exploratory testing back in the days really kind of made the point of, let's bring these two things together. We have other ways of splitting the work when we need to scale in teams. We don't need to scale it by passing it through a piece of documentation. But then looking at this, there's this question of, well, where's the manual versus automated here? Like if there is even that versus thing. So I intentionally kind of drew that arrow the other way around. And we had still the idea kind of in the world that as exploratory testing grew on, we thought of it as in like the manual part was somehow exploratory, but the automated part, we started talking about it with different terms. And I'm not into that different term of kind of like correcting the language on that side as well. But more on the side of realizing that you can't really split these two, because these kind of interlace and feed into one another on the test execution side. And the design is still something where someone is thinking, what do we want that automation to do? And got also forward, and design started seeing nice tool support. I've been doing some model-based testing and realizing that you can actually draw a state model that can generate you test cases. And depending on how you can describe these common oracles, like partial oracles that help you see problems when you're going through these different paths based on that model, you can also automate a lot of this. And again, it is a lot of power required activity to design those models in a way that actually maintains that agency. So all together, I've started to kind of talk about contemporary exploratory testing. So I still think this is actually the same that Ken Cater thought about those 37 years ago, watching people do smart work, but the way of thinking about it is that the manual and automated cannot be separated for the exact same reason that we've been arguing over on the test design and the execution part, because if you separate them, you're losing some of the agency. And while you could imagine having really great collaboration between different kinds of testers, like someone who is specializing in the manual work and someone specializing in the automated work, I find that it's much more rare than I'd like for people to effectively pair, or effectively ensemble, bring more people together on the actual work that it's been doing. And whenever you pass it as a kind of like documentation or mention, you are losing a lot of the context that would enable better learning if you didn't create that separation. So what I'm asking nowadays from my colleagues at work is that no matter where we come, whether we come from kind of like starting with as our first idea, or start by the manual perspective as our first idea, we come together on the hands-on work. And over the years that I've now done this, it is actually next to impossible to say whether we are doing manual or automated testing. We are effectively intertwining those in the work that we are doing. So let's talk about that a little bit more. The belief that I've grown into is that we can't actually automate well without actively exploring while we're trying to automate. You have to look at the APIs, you have to look at the interfaces that you're using, you have to look at the GUI if you're automating through the GUI, you have to look at the little code snippets that you're trying to create things against, so that you can effectively automate. You need to understand how things have been implemented, at least a little bit, so that you can do effective automation and design test cases that are going to be maintainable and usable. So there's a lot of power required to that. And there's some brilliant testers out there who are doing exactly this. But on the other side as well, you can't really explore well without automating. Like cutting out certain things that you just cannot do if you have no means of programming at your hands. Like, for example, one of the things one of my colleagues was doing is that every day he would kind of update his scripts and he would leave them running for the night, so that the next night he would know if those scripts were finding something during the night. And he found really interesting reliability problems in the embedded system. It needed to run over the night. It needed more time. And there's absolutely no sense in him kind of observing all of that time, what is going on. But when he saw his results the next morning, he knew that he got some hints, but he needed something more. So he was kind of going back to updating his scripts, then doing some log analysis, searching through the logs that he had created to find those patterns. And he is the epitome of exploratory testing and doing it well, at least in the world that I live in. So I think these two are much more intertwined. So what I then want to do next is to show you what this looks like in practice. So I can use the real examples from work in most of my talks. I can't talk about all the bugs that we find, but of course I can give you examples, especially when we're having conversations, if you like. But what I want to use as a sample is this little teaching application that I've been using recently, and just showing how to do exploratory testing really well. So I've been building this course called Exploratory Testing Foundations. And the basic idea with that course style is that we just take some test target. Like the first course was around this E prime. I have another one where I've been using now OpenOffice and particular aspects of OpenOffice, trying to kind of like figure out same kind of lessons on hands-on on what you can do there. With E prime, the basic idea is really, really simple. So I can write some text into the file, I can click on the button, and what it does for me is that it makes sure if the text that I'm writing is so-called proper E prime, so it should avoid the verb to be. The UI might not be perfect, so we might already be giving some kind of like, in our minds feedback on the UI. But what we usually do starting testing something like this, even before we automate, we just want to see it run in some way. So I've given the developers example here on this slide. So to be or not to be, Hamlet's dilemma. It shows you both discouraged words and possible violations. You might be wondering, what is this possible violation? Why is the possessive marked with yellow, with blue rather than red? And my current working theory is that it's a little bit of a laziness on the implementation, that when you don't actually know whether this would be a to be verb or if it is a possessive, then it's an easier thing to create a separate category for the things that you have to kind of, add some manual interpretation on. And I think it's also like a nice example of this whole contemporary exploratory testing idea works. So, playing with this application, putting in different kinds of inputs, paying attention to details. If you pay attention to details, you might know that there actually isn't 9 words here. There's 8 words only. So there's already about in the demo version. So usually this is not usually the demo version that I would get from the team that I work with. They usually have something that they know would work. And I've chosen this specifically. Good example. So depending on what you're paying attention to and what is first, if you first see the bug, I've watched some people test this, basically pair with me, so that I try to kind of take a little bit of a backseat and just kind of be actively participating and working with whoever is on this, also in the ensemble format. If they see the bug first, it might be a trap for people, that the bug kind of takes their focus. And I've had people test word counts and how word count fail for a full hour. And this application isn't called word counter, it's called E prime. So we spend an hour without doing anything about the problems domain, and I call that a trap. Another thing that I've seen happen with other people, just with a simple application like this, is that they notice that, oh, there's this nice sentence, and you can imagine how I'll automate this. Especially people with a lot of automation background, they might kind of want to go into, let's figure out how we can make this something that we can always verify. And we have like a little bit of a piece of code that does the verification. It's not an impossible thing to do, but it actually, when you start doing it at a time when you don't know all the rules of how this will end up working, it might be that you didn't build the right thing, but it easily takes you that first hour that you're spending with the application. Other people notice that there's this link, and they click on the link, and it opens you a specification. And I've seen people lose themselves for the 1 hour of analyzing the specification on what are the test cases I would run if I ever would touch the application. And I've also seen people kind of start with the idea that, you can put data, let's put something really, really big. And a lot of people actually with something really, really big before they have even seen it work once. We actually, when we are exploratory testing, we are trying to take steps where we don't get it, but at the same time, we are kind of growing our understanding. It's not just kind of random inserting some text so you can make the application fail. You don't know if it fails in a relevant way, and we would expect that out of a good testing effort, that you would understand the relevance of the problem as well. You don't get that if you just randomly start putting in stuff. So you actually have to put some thought into this. So having watched maybe 10, 20 different groups of different sizes work with this application, I've collected all the bugs we found. And this is a very typical kind of like an outcome of exploratory testing, the mind map that has some kind of like, nodes here, describing what kind of things are there. It might be more or less detailed. This is much less detailed because the focus here is on the fact that heads are bugs that this little application has. And when we're given something like this, we're given open-ended, test this once now, but keep testing as time goes on. That's always the implicit assignment. And the canvas is empty when we start. It is always about finding bugs that someone else has missed so far, some of them existing right now, or some of them born in the future. That's the assignment that we work with when we're testing. Similarly, out of these sessions, one of the sessions with Parveen Khan, we created a test strategy. Interestingly, the test strategy isn't input to testing. That's not how test strategies work. Test strategies are outputs of some tests, and they can be inputs into the future testing that you do. So we had already spent several hours with the application, playing with automation, playing with without automation, trying out various kinds of things before we were ready to write this test strategy. But just to give you an example, this might be something that someone expects you to write. So exploratory testing isn't without documentation. It's just that it's more likely your documentation is output than input. But this then takes us to the other type of document, which I in particular want to emphasize with this automationist Gambit, and that's test automation. So actually, in my experience, test automation is one of the best ways to document. If the organization is asking me, like mine is, detailed test cases, it's better use of my time in creating those detailed test cases in a format where I can rerun them next time. So the way that I have done it with this example is by using robot framework. And before I show you the robot framework examples, I just want to quote one of my colleagues at work. And they said one of these days when we were about robot framework that, you know, it makes very easy things easy and the hard things even harder. And we are really trying to move away from it. We are moving to PyTest and just kind of like closer to not a specialized testing language and code style, but like, you know, the general purpose programming languages, whatever is local to the teams. But it's a really nice and tempting way of showing people don't know what automation is about, what you do. So what I usually do in those sessions with people is that we write with robot framework kind of line by line. We start by filling some text so that we can, you know, do the same things that we could do manually, put the text into that field. We could click things, we could check how many words, how many discouraged words, and just control the input text. And it doesn't actually take long for even a complete newbie who has never ever written automation to do this. It's usually 10-15 minutes pairing with me, and they've created this. And after the second step, they're already kind of like, you know, comfortable, like, oh, I know what I need to do next. It feels that common and that familiar when you get started with it. And the only kind of, you know, benefit out of this this style that robot framework gives me is that there's so little gap between the way that people think already and this particular tool, that they get kind of over that hurdle of, oh, now I'm automating almost immediately. I've done this with business people in Vaisala who are running business systems, and I've done this kind of with a lot of different kinds of people. And, you know, it's something that is teachable. But it also, this style of creating the first case, it allows me then to have these kind of like, you know, variables here where I can start playing with it. So after I've run it first time, seen the green, I can actually very easily just turn it into a template. And I might not have done any manual testing on these cases before. I might just be writing them here as in like, let's try that text and so on. And this is how many words I expect. This is how many kind of red words I expect to see. And again, it's the same thing refactored, just a little bit lower into keywords that allows me to do this. So not a big thing to teach in like a 1 hour session. Different groups end up with different number of texts. And this is a very critical one from a group that then goes into the specification and finds that in the specification, all these words should be recognized. And with the number 6, we also see the red for a reason. So to the specification, some of these words, particularly the .re, actually should be recognized as E prime, and they are not. So our test, without even writing that there in the user interface manually, are already revealing us first time new bugs. So we have the documentation, we can run it, and we can kind of control it. So it grows from a single line to, you know, just trusting your tool, seeing it fail, to the first test, seeing the same test but with variables, having the same test but now with templates, so that then you can start adding the different examples, you can start seeing bugs. You use all of your test design power in thinking what kind of inputs would make sense here. You turn the whole specification maybe into tests. You guess all the values that you think might fail. You might run it on all the different browsers, and you might run it over time, except if you have that failing test with a bug, you need to address that before you put this test in the CI. You do not want to find the bug in every single run. But this documentation style, it's just, you know, it's doing exactly the same things that I've always done as a tester. I've always documented, I've needed to leave some behind, but it's also giving me a chance of making this choice of leaving this behind as something that I keep, or I might just throw it away. But it is also a really nice way of documenting. So in spending that 1 hour and all the traps we talked about, what usually happens is that people end up with a few examples. They have some specified examples that, you know, are not properly recognized, but also like knowing the whole list of bugs, they don't follow them within that 1 hour. But none of the approaches that I use for exploratory testing on that application finds all the bugs within 1 hour. You need to use multiple hours. So nothing says that you couldn't do this in your very first hour. You can do this on your second hour as well, but being aware that you are actually, by the rules of what is exploratory testing, you, the tester, are going to make those choices. And the only thing that really limits your choices is whether you have acquired this to do this. It moves that responsibility a little bit into us considering how could we learn these skills. And since I've had people who learn to do this within a few months, properly supported as part of their day-to-day job, we are not talking about rocket science. So yes, you're right, this is not rocket science that I'm talking about here, but it requires you to get people who are pairing and helping you figure things out. You hit your head against the wall alone a lot, but properly supported. This is a learnable skill. So I can use automation for documenting, but I definitely can use it for repeating. I can use it for kind of like, tell me in the morning or tell me right after someone changed something that I need to go and explore some more. I can use it to give me kind of forcibly look at details I wouldn't be looking at otherwise, because I need to understand the detail, able to automate. And all of this is within our reach. So we, as testers, we are making these choices. And this is then moving our attention kind of into learning, whether we are present in the moment or whether we are collecting information and then attending to it. The cycle is not between manual and automated, but attended and unattended. And on the layers, we can do it on any of the layers. So again, it's not just on the UI level, even though my example was on UI level, I do a lot of this on the unit testing level. So this all boils down to the idea that you can test, not all automating people can test. That's unfortunately a reality when I recruit. We have people who write a lot of automation, but they need someone else to tell them how to test. Whether you can code, we have people who can't code, and similarly than the people who can test, those people can learn to code. The most difficult skill is the collaboration. Can we actually do it so that we are really collaborating and not just nicely talking to one another over the whole virtual hallways that we have, but also do we have ideas on how to do this better? So can we learn on all of these aspects? So it kind of goes back to this idea that we started with, the opportunity cost. Every time we're making choices of what will I do with my time today? And when we're doing something, it is time away from something else. But it's not just choices of, do I get to play soccer today? But it's also whether I will update my skills on riding the scooter. So we need to kind of like do balanced choices. In the moment, they seem like they're away from one another, but in the long term, they're not. And I really like this kind of saying from Venkat that it's not enough these days to be employed. It's also important to be re-employable. And just looking at the job market in Finland, the fact is that without automation, you won't be re-employable for very long. Unless you have 25 years of experience like I do, you don't have to write automation, but you're better off with automation skills. But it is not the automation that makes you employable. It is one part of it. When you can put these skills together and use them to do really powerful, resultful testing, that's what the employees are looking for. So in conclusion, what I call now Automationist Gambit, or Gambit in general, it is an opening with an appearance of sacrifice. You need to look into your own heart and know where you feel you are making a sacrifice. And recognizing that you feel you're making a sacrifice is okay. But that sacrifice might be actually changing the end game you're playing. And I believe we should seriously be considering that. So that's the talk.